Heat constantly flows from hot to cold all around us. Take the whooping crane. It stands hours on end in cold water. How does it warm its legs? Well, its legs serve as heat exchangers. Warm blood flows down its legs, heating the cold blood that flows back up. We call that a counterflow heat exchanger. Heat transfer is everywhere in nature. It's everywhere in the machinery of everyday life, and an exchange of heat is how we turn natural gas into liquid. LNG plants generally use three types of heat exchangers. Fin fan exchangers, much like those on the backs of our refrigerators, cool the refrigerants. But the heart of an LNG plant is the exchanger that cools the natural gas. The two types are coil-wound and plate-fin. Coil-wound heat exchangers have been around the longest. They evolved from 19th century locomotive boilers. Today, we wind multiple layers of tubes inside a pressure vessel shell. Natural gas and high-pressure refrigerant both cool as they flow up inside the tubes. Very cold refrigerant flows down around the tubes in the shell. Those wound tubes can provide a heating surface as great as 40,000 square meters. These units are compact, but they're big. One might weigh over 250 tons and look like a gigantic spark plug, or maybe like a Saturn rocket. We can build these units for all kinds of fluids, pressures, and temperature ranges. They transfer an amazing amount of heat in a given space. The other widely used LNG exchanger is the plate-fin type. They're smaller and lighter than coil-wound exchangers, and we can easily scale them from small to large sizes. A look inside shows how it works. Fluids move through alternating layers of corrugated fins separated by flat plates, transferring heat between natural gas and refrigerants. Those fins enhance heat transfer from the fluid, and they conduct more heat directly into the plates. These layers of fins and plates can be combined in many configurations. We arrange the flows so as to optimize the heat transfer. The aluminum plates are brazed together. We attach headers to the stack to direct the streams of refrigerants and the natural gas. Then we install all this in a cold box. This heavily insulated box keeps everything cold. That gives operators more flexibility during steady and changing conditions. Plate-fin exchangers transfer around 6 times as much heat in a given space as coil-wound exchangers do. But coil-wound exchangers can hold pressures all the way up to 250 times 1 atmosphere. And we can make them from different materials. So, 2 different heat exchangers. Each finds its place in specific liquefaction processes that we humans have designed and developed over decades. And we finally achieve on a vast scale what that whooping crane's legs have long done in